Hi, everyone, and welcome to day one of 27.1. And that is going to begin us talking about ellipses. And an ellipse is kind of the oval shaped portion of our double mapped cone cross section. And it has a couple of key components. One is the major axis, which is always going to be the longer of the two axes, so either horizontal or vertical. And then there is a minor axis, which is the shorter of the two. There are also two foci, one focus on each part of the major axis, similar to kind of in our parabolas how we had a focus, and that we have two, and they're always located on our major axis and inside points there. There is a center of an ellipse as well, and the endpoints of the major axis are called our vertices. Okay, so a lot of key vocab here that's coming either from your book or the supplemental notes handout that's attached to this as well. Or of course, you can always keep these notes in a notebook. Okay. Now, connecting this to some of the information we've already talked about, is a circle an ellipse? Well, the answer here is yes. Officially, a circle is an ellipse in which the length of the major axis is equal to the length of the minor axis. So officially, we can write a circle in the form of an ellipse. So what that means is basically what we'd be saying is that A and B would have to be equal to each other. So this for a circle, A is going to equal B, these two parameters here. And again, the length of the major axis and the length of the minor axis would have to be the exact same. So if we connect this back to talking about the equation of a circle, basically instead of being x squared plus y squared, if we're centered at the origin, equals r squared, if this was an ellipse, and we actually did some examples like this when we talked about completing the squares and circles, what we're saying instead is it's a circle that's in this form, x squared over r squared plus y squared. Again, this value would be the same for a squared and b squared equals 1. Okay, something you're going to notice about our ellipses is that they are always equal to 1. Okay, and again, this would be if that circle was written in ellipse form. Okay, now in general, however, they're not going to be the same. And if your major axis is horizontal, so you're more along this way, the A value, which is always going to be the bigger value, would be under your X values. If it was a vertical major axis, notice the A value is under the Y. So the bigger number is going to be under the where the major axis is going to be located either on X or Y. Okay, so it's really important to have these written down. And again, similar to a circle, H comma K is our center. And then we're going to have 2 times A is the length of the entire major axis. 2 times B is going to be the length of the minor axis. And then C is the distance from foci to foci. And we find C squared by doing A squared minus B squared, because again, A squared is the biggest. Okay, and all this is on there, but you definitely want to make note that A is the biggest of the 3 parameters in our ellipse. Okay. Now, how do we actually sketch and do an ellipse in this process? So something we're going to notice here is we have this equation. Notice our H and our K value, we're going to be centered at 0, 0, because H comma K is 0 and 0, since it's just x squared and y squared, so we're going to put that center at the origin. Okay, and our A parameter this time, the A value is the bigger value, so A squared is 9, which means that A is going to be the square root of that, so just 3, which means because it's underneath the Y values, that means we are 3 units from the center on each of our 2 axes. And then B squared this time is 8. So if we square root that, the square root of 8 is 2 square root 2, or approximately 2.8, because that's going to help us graph it if we know the decimal approximation, right? So we would be on, since this is underneath the X values, 2.8 to the right, 2.8 to the left of our center. And then last but not least, we need parameter C. Now, reminder that C squared is going to be equal to A squared minus B squared. So C squared is 1, which means C is 1. and that's going to be on our major axis, again, where the A parameter lies at. So these would both be located 1 unit from our center on the y-axis. And to graph this officially, we would just connect the endpoints of our major and minor axis to see our ellipse. Okay. So some key features where things are located at, again, we said the center is at 0, 0. And then the two vertices, aka the endpoints of our major axis, are at 0, 3 and 0, -3. The co-vertices, or the endpoints of the minor axis, the co-vertices, those were at 2 square root 2, 0 and -2 square root 2, 0. And then last but not least, our two foci are located at 0, 1 and 0, -1. Now, sometimes our equations are not going to be given to us in standard form, so we are going to have to complete the square in order to find these values. So we want to complete the square and then kind of repeat the process from up above as well. So when we complete the square, this goes back to what we talked about when we initially talked about circles, that we want to group these so that all of our squared parameters are with their unsquared parameters that, kind of share that variable. And then we're going to move, since this 36 doesn't have a variable, we're going to subtract that to the other side. And a reminder, whatever you add to the left, you are going to have to add to the right. Now, before we figure out what to square and add in, what we're going to do, similar to what we did the last time, is we need to take out a greatest common factor here. So we have a 9 that is able to be taken out of the first piece, and we have a 4 that would be able to be the greatest common factor between the second piece. And then, again, we're going to be adding those two things to the other side. So a reminder, whatever you're adding to the other side, you're going to want to do 9 times that value and 4 times that value because you took that GCF out. So when we divide the 4 by 2 and square it, we end up adding 4 to our blank. But a reminder, you're not just adding 4 to the other side, you're adding 9 times 4, aka 36 to the other side, because really that's what's on the left-hand side, what we're adding in, but we had factored out that GCF of 9. And then same idea over here, -6 divided by 2 is -3, squared is 9. But again, you're not adding just 9 to the other side, you're adding 4 times 9. So again, another 36. Okay, so just be careful of what you're really adding to both sides with your ellipse. Now, when we factor, we still have x plus 2 in parentheses. Notice we still have that 9 out front. And then we have y minus 3 in parentheses, and we factor there. And then -36 plus 36 is 0, plus another 36 is 36. Now, we know our ellipses always equal 1. So the last step here is to divide everything by this 36 and simplify because we need this equal to 1. Okay, so our final equation here, the 9 and the 36 are going to simplify to be 1 over 4. So x plus 2 quantity squared over 4 plus 4 over 36, which is 1/9. So y minus 3 quantity squared over 9 equals 1. So there's our equation. And from there, we're going to be able to look at some of these examples. Okay, so again, if we're looking for A, this time that's the bigger value here. A squared is 9, so A is 3. B squared is 4, so B is the square root of that, or 2. And then C is going to be found by taking A squared minus B squared. So C squared is 5, which means C is the square root of 5. Okay. So our center this time, H comma K, we're at -2, 3. And since our A parameter is underneath the Y's, we're going to be moving up and down from our center to get the vertice values, okay? So our vertices would be moving up and down from -2, 3 units up and 3 units down. So they would be at -2, 6 when we move up and -2, 0 when we move down. The co-vertices then are, again, our minor axis. Again, we're moving left and right 2 units from our center. So left 2 units would put us at -4, 3. Right 2 units from -2, 3 would be at 0, 3. And then last but not least, our foci are going to be to the right and left, or excuse me, up and down, since again we're vertical of this value here. So we would say we're going up square root 5 from 3, and we're going down square root 5 from 3. Okay, let's take one more example here, looking at completing the square. So again, when we start this, we want to start by arranging and looking at what's going to need to be moved to the other side and what is going to need to actually be factored out a GCF, because here we notice we don't have a coefficient on the x squared, so that's just going to stay x squared minus 4x. We will complete the square on it, but we don't have to worry about a GCF. The y values, however, there's that coefficient of 4 here, so we're going to factor out a 4 out of both of these terms. We're left with y squared minus 4y, and then we'll be adding a blank to that. So on the other side, we have the -16, and we're going to be adding, again, 2 things to that, and we need to be careful because the second one will be 4 times whatever we added to the blank. So with the x's, we have -4 divided by 2. It's -2. Squared is 4. Add that to both sides. And then be careful. Actually, you're adding, again, to the blank itself, a 4 again. But when we add to the other side, remember it's 4 times 4, aka 16 is really what's getting added to the right-hand side. So we end up with x minus 2 quantity squared plus 4 times y minus 2 quantity squared. -16 plus 16 is 0, so this all equals 4. And then divide everything by that 4 to get our values here. So we have, x minus 2 quantity squared all over 4. The 4's here are actually going to cancel, and we would just have a 1 in the denominator, and just equals 1. Okay. So this time the center is at 2, 2. And if we check out our parameters, a this time is underneath our x values. So a squared is 4, a is going to be 2, b squared is under the y's, it's going to be 1, and we square root 1. And then c squared is a squared minus b squared, so 3, aka c is the square root of that. So our vertices this time are going to be to the left and right of our center 2 units. So at 0, 2 and 4, 2 when we move to the right. The co-vertices then are going to be moving up and down from our center. So we would be at 2, 2 plus the square root of 3 when we move up, or minus the square root of 3 when we move down. And then last but not least, those foci are going to be on the major axis this time, so moving left and right. Oh, shoot. Just realized that's actually the answer here. Did this wrong. Pardon me. We're moving up and down 1 unit from here, so this could actually just be 3 and 1. So sorry about that. And then the foci then are going to be at moving left and right. 2 plus square root of 3 would be to the right. 2 minus the square root of 3 would be to the left. So sorry, that's a little mistake. All right, last piece of these notes is getting us introduced into the idea of writing the equation. So this time they are giving us the center, so h comma k, and then they're giving us a focus being at 8 comma 2. So this is, again, if you know the focus, you're going to know the length of c. Now notice that they changed the x parameter here 3 units. Okay, so that's how we can kind of determine that. We also now are going to be able to determine that this is going to be a horizontal shaped axis because we changed the x values and we know the foci lie on that major axis. Okay, they also told us one vertex is at 10, 2. So again, going from the center to that vertex, that's going to be our a parameter, and we had to move 5 units on that one. So we know a and we know c here. And we also know that when we plug this in, x minus h quantity squared plus y minus k quantity squared equals 1, we know that our a parameter is going to come under x this time because that's going to be our major axis because that's what we were changing for those a and c values, okay? So we can plug in our 5 squared here for x, and then we can also plug in 5 and 2. So actually this should be coming kind of underneath, the part down here, the part B is actually where a lot of this is going to be coming from. So we have 5 squared here now, and then again we plugged in 5 and 2. Okay. Now the other piece of this though wants the location of the other focus and the other vertex. So again, if we are at 5 comma 2 as our center point, we went to the right 3 units to get the first focus. So we would have to go to the left 3 units to get the other focus. So the other focus is going to be at 2 comma 2 since we had to go to the left. And for our other vertex, we had to go to, we went to the right. This time we'd have to go to the left again of this. So we'd be at 0 comma 2 since we have to move a parameters. Now, we started filling in the equation here, but the last piece of this then is figuring out what our missing b parameter is. Now, reminder, c squared equals a squared minus b squared here. So we know that our c parameter was 3, our a parameter was 5. So if we start solving, 9 equals 25 minus b squared. So that means that b, if we move this all around, is going to have to be, b squared is going to have to be 25 minus 9, which is 16. So we can plug that 16 in for b squared to get our final answer here. If we make this a little bit cleaner, the 5 squared we said was 25, and then again, this is now 16. So thanks for watching the introduction here to our ellipses. Again, make sure that you have these formulas written down so we can work more with these in class.